Hey guys, Mr. Backenberg here. In this video we're going to be looking at the intermediate value theorem. So the intermediate value theorem says that if we are dealing with some real numbers a and b, where a is smaller than b, and our function is continuous on the interval between a and b, then our f function is going to take on every value between f of a and f of b. So let's think about this graphically. So let's take a look at a picture and say this point right here is the point a comma f of a, and this point over here is b comma f of b. Then what's happening with the intermediate value theorem, as long as our graph is continuous between those 2 points, then somewhere along the line we're going to be able to find any y value between f of a and f of b. So we're going to have some point in there that we can say is c and f of c, and that f of c value is going to be between our f of a and f of b values. Now this works out pretty handy when we're looking at finding zeros of functions. So when I'm thinking about my a and f of a point, let's say that f of a is going to be a positive number, so we're going to say that f of a is greater than 0. And when I think about my b and f of b point, let's think about f of b as being a negative value. So f of b is going to be less than 0. Then, based on this intermediate value theorem, as long as my graph is continuous between those 2 points, then somewhere along the line our graph is going to have to cross through the x-intercept. So there's going to be a y value in there where we've got c comma 0. So we're going to take a look at a function in here, and we're going to do a little graphing to try to find some x-intercepts or some zeros. So we're going to look at the function f of x equals x to the 4th minus 0.1x cubed minus 6.5x squared plus 7.9x minus 2.4. And I'm going to graph this one out on my calculator. So I've got my function typed into my calculator. When I hit graph, depending on what your window is at, we may or may not be able to see all of the zeros happening. Right now, as we're taking a look at this picture, it looks like maybe we've got one happening at about -3, and maybe another one happening at about 1. So if I go ahead and find that 0 on the far left-hand side, I go second, trace, and I pick option number 2. I'm going to do my left bound and my right bound using this point on the far left-hand side. So left bound, enter, arrow over to the right, hit enter, enter, and we've got a 0 at about -3.01. Now on the right hand side it looks like we've got another 0 happening at +1, but I'm actually going to zoom in there to see what's happening. And if I zoom in, I can actually see that there are 3 different zeros happening in here. So when I do second calc and find the zeros, I'm going to need to do each one individually. So if I do my left bound point, and I do my right bound point, enter, enter, we've got another one happening at about 0.51. Then if we go a little bit further over to find our next 0, our next one is happening at about 0.92, and then our last 0 is happening at about 1.68. So as we're taking a look at a picture of a graph, we need to be careful to make sure that we really know what's happening with the graph of our function before we just assume things about it. So when we initially looked at our picture, it looked like there was only 2 zeros happening, but in fact with this quartic function there were 4 separate zeros. That's going to be it for this video. Thanks for watching.